From working through the bowling task, I know that the Bowling Bonanza charges $2.50 for each player to rent shoes, and it's $20 per hour for a group of 4 to bowl. And I worked through the writing the coordinates of point A, which is here, so that was a time of 4 hours, costs me $90. And I can also draw the line. So there's the line. I know that it's a linear relationship because it has a consistent rate of change of $20 per hour. So I could draw in a rate of change at any of these points. So for example, for 1 hour, it costs $30, and I can go across to 3 hours and see that it costs $70. And that follows with the idea of the rate of change being $20 per hour. And I'm looking at the value for 3 hours, so that's going to be 3 times 20. But I also need to have the cost from the shoes, which they only pay once, but there's 4 people, so it's $2.50 times 4, or $10. And this $10 is going to be my constant here, so I add 10, and that gives me the value 70. That's this output, that checks out, that's on the line. Also, I know that if I have no hours whatsoever, I'm paying the $10, so that's this point on the line. So again, I know that it's a straight line because it has a constant rate of change, and I even know the starting value, the y-intercept, is $10. Since I have the relationship here with dollars per hour and starting value, then I could also write the equation of the line. So I'm going to zoom out. So I can write the equation of my line since I know the rate of change. Having zoomed out here, I have $20 is my change in time, and I have to always pay $10, and this is related to the cost, so C equals 20t plus 10. Now I know the equation of this line. In the next part of the question, I'm asked to compare this Super Bowl, which is a new place, with the Bowling Bonanza place. So I'm going to write down the equation of the line of the Bowling Bonanza that I know. The cost is equal to 20 times time plus 10. And I got to figure out what the Super Bowl one is. So this is for bowling. And for the Super Bowl, it says it's just $3 for a game for each player. So the cost here has nothing to do with time. The cost is $3 times players. So it would be hard to compare these two. They're both about cost, so C is cost and C is cost, but this one's about time played and this one is about the number of players. Now they do ask me to compare whether they should go bowling at Bowling Bonanza or Super Bowl, but I know that William is playing 6 games and he has 3 friends. So I can now use the information about the number of friends to answer this question, and the fact that they're playing 6 games to answer using Bowling Bonanza. Okay, so the information about Bowling Bonanza is the cost is 20 times the number of hours plus 10, and they told me up here that they're going to play 6 games in 3 hours. So 3 hours is a time, so I'm going to use that for T. So C is equal to 20 times 3 plus 10. 20 times 3 plus 10 I figured out earlier, that is 70. Now I also need to consider the other place, the Super Bowl. So Super Bowl has the cost equation of 3 times the number of players, and we were told that William and his friends, so that's actually going to be 4 people, so P equals 4. So if I put the cost in here, I get 3 times 4, so it's going to cost me $12. Now this is the cost for just one game, so I need to consider the number of games that are played. So they said that the games played is 6, so I'm going to actually have to multiply this cost by 6. So the total cost is 12 times 6, which equals 72. So the total cost here is $72 for the Super Bowl. So it's actually cheaper than for William and his friends to go to Bowling Bonanza. Hold on a minute here. When we did the cost of 10, that was for 4 friends with shoes at $2.50 each. But this time, that's not true. This time it's 6 friends at $2.50 each. So my initial value isn't going to be 10 anymore. 6 times 250 is going to be $15. So if I change this to now read C equals 20 times 3 plus 15, then my cost will be $5 more than before. My cost will be $75. So actually the new place Super Bowl is the better choice.